Hello all, once again welcome to our channel Physi Dive, and today we are going to learn about a very important topic in class 10 NCRT, that is image formation by a concave mirror. So this is your teacher Alexi Rajan, so we will just dive straight to the class. So to the class. So there are certain prerequisites in this before studying the chapter or before studying the topic. So what are those prerequisites that we are going to learn right now? Okay, so there are certain rules while we are dealing with the mirrors. So first and foremost thing is that we are going to take the case of a concave mirror, and you know this is a concave mirror and what are the different terminologies that we have studied. This is a pole center of the mirror, and this is a focus, and definitely this will be the center of curvature that we have learned right now. Okay, now a basic physics, a rule is there, that is, if two rays are coming from infinity, and make sure that these two rays are coming from a single point, then while reaching the mirrors, then they will be parallel to each other. It is not necessary that they should this two mirrors should be these two rays should be parallel to the principal axis. No, there is no rules like that, but they will be parallel to each other. If this is ray 1, this is ray 2, then these two rays will be parallel throughout. These two rays will be parallel throughout. So this is one of the law that you need to learn, and this is well explained as light is not a particle, instead it is also acting like a wave. So it is also acting like a wave, and in 12th standard you will study about wavefront. If a wave is coming from a source, then obviously certain wavefronts will be formed there on reaching or while they uh, pass by, and while they reach the infinity, then definitely these rays will be parallel to each other. They will be parallel to each other. So if two wavefronts are there, then they will be parallel to each other. This is one of the prerequisites. That is, once again I'm saying, if a ray is coming, if two rays are coming from a single point, even though they are diverging by a concept, that is, on reaching infinity, then definitely they will be parallel to each other. So this is one of the prerequisites. Now I'm just discussing some of the things which we have, some of the basic ideas that we have learned in the previous session, that is real image and virtual image. So real images are those image which so that can be formed on a screen is known as a real image, whereas virtual image are those images that can't be formed on a screen. So one is produced in a screen, the other one will not be produced on a screen. So these are the basic ideas. And one more thing is that real images will always be inverted, whereas virtual images are erect. And a very important thing is there, that is image distance and object distance, or simply V and U. A mirror is kept here. If you're keeping an object somewhere here, this object is AB, then this one is P. So the distance between pole and the object is known as what? Object distance. So just imagine that this object is forming an image here. Then the distance between pole and the image represented by V, and this is known as what? Image distance. So one is object distance, the other one is image distance. So these are the prerequisites that you need to know before studying the coming session. So after studying the prerequisites, now we are getting into a very important topic, that is the image formation by a concave mirror. Image formation by a concave mirror. So here is a diagram of a concave mirror. There you can see certain points, that is P, F and C. So here what we are going to do is that we are going to place the object at different places and see where the image is formed. So for that, we'll find certain positions. And there are 6 positions mainly. The first position is the simplest one, that is, we are keeping the image at infinity. We are keeping the image at infinity and see where the image is formed. So infinity is somewhere beyond the sphere of influence. So it can be anywhere beyond the sphere of influence. So that is one case. And the second case is that we are keeping the object beyond C, and between this this infinity. So that is 2 points that we are going to learn at first. That is object at infinity, and we are keeping the object, next case, we're keeping the object beyond C. Then what we are going to see, that is at somewhere here at infinity, and beyond C is the object is now somewhere here, so that it is beyond C. So then what we are going to do is that we are going to keep the object at C. We are going to keep the object at C and see where the image is formed there, and say this object named AB. Okay. Now what we are going to do is that, and after finding that particular case, we are going to keep the object between C and F. Between CF. Now it is between C and F, and see where the image is formed there. Then the next case is that at F, and the next case is that between F and P. So here at each case we will just find it out where the image is formed there. So these are the 6 cases that we are going to study one by one thoroughly. It is very important for your board exam. So stay tuned, take your books with your pencil and see what is going to happen. You will also pause the video and see how you can draw the things. The first and foremost case is object is placed at infinity. From infinity, if 2 rays are coming from a single point, then they will be parallel to each other. Know the idea that we have learned at the previous session, and this will be seen. I will just put somewhere here, so you can just go through that particular video also, and you can understand. If anyone is not knowing, that you can go through that particular video. Okay. Now, so here 2 rays are parallel to the principal axis. The first ray will be passing through the focus, and the second ray will also pass through the focus. And you know, if 2 reflected rays are meeting at any point, then at that particular point you will get the image. At this point, the 2 reflected rays are meeting, and then definitely you know, that is at that point you will form, there will be an image formed, or there you will get the image. So that is a case there. But here the issue is that you will not understand what is there. Why? Because it is a point size image. So it is not necessary always that these 2 rays should be parallel to the principal axis. It's parallel, and the other way around also. It can come from any point, but they will be parallel. The rays will be parallel as they are coming from a single point, and they are coming from infinity. So you should keep that thing in your mind. So if they are not parallel to the principal axis, then definitely somewhere at the focal plane the image will be formed. So that is the first case that you should know. Now the question is that you need to write down, or you need to see what are the properties of the image formed there. And first and foremost thing is that the object is placed at infinity. So image will be formed. Now that is image, where what is the position of the image? The image is formed at the focus, or more precisely we can say the principal focus, as they are parallel to the principal axis. And the next thing is that they are real. They are meeting, the rays, the reflected rays are meeting in real, so definitely they are real. And all the real images will be inverted, and they're highly diminished, because here in this case also you can see they are point size, though, so they are highly diminished. So these are the properties that you can find out in this particular case. Now the next case is that when object is placed beyond C, where will be the image formed, and what are the various properties of the image formed there. Now this is a diagram. So this is a scenario. Make sure that these 2 distances are approximate while drawing. You have seen that particular property in the previous videos and all. Okay, so here just imagine that if from this particular point a ray is moving parallel to the principal axis, then definitely after reflection through the principal focus they will move, right? So this is one condition. Now the next thing is that I'm just taking another ray which is coming from the same point and passing through the principal focus. Then definitely after reflection they will pass parallel to the principal axis and they will meet at this very point. And at this very point the image is formed, and this point will be A dash and this will be B dash. So here observe the image very clearly. Where is it formed? So you can see the image is formed. So you can see that the image is formed between C and F, and they are meeting. The reflected rays are meeting in real, so definitely you will get what? A real image. And you know all the real images are inverted. All the real images are inverted, and in this case you can see obviously the image formed is smaller than the object there, so it is diminished. So these are the various properties. Moving on to the next case, that is when object is placed at C. So we'll see where the image will be formed. Okay, let us take the two same condition. Let a ray move from this particular point A parallel to the principal axis, then definitely you can see they will pass through the focus and go like this, right? Now the next thing, the next ray will be passing through the principal focus, and after reflection it will just move parallel to the principal axis, and somewhere here they will meet, right? At this point you can see the image will be formed. That is exactly at C the image will be formed. And one more very important thing is that if you see the size, definitely both the size are equal. Both the sides are equal. So what are the different properties you have seen here? So these are the various properties you can see here, that is image is formed at C. So here at the same position, if you keep a screen, then definitely you will get an image of the same object. And the next one is that they are real because they are meeting who? The reflected rays are meeting in real, so you will get a real image. All the real images are inverted and you can see a same size image there. That is AB will be equal to A dash B dash. So these are the various properties if you keep you will get if you keep the object at C. So moving on to the next case, that is if you keep the object between C and F. So this is a scenario here. So the same case I'm going to take, that is a ray is passing or moving from a point A and it is passing parallel to the principal axis, so definitely it will pass through the focus and moves like that. It is not necessary that you should take the same condition which I am taking. You can also take, I'm just taking another ray which is passing through the principal focus, and definitely after reflection, this line will be passing parallel to the principal axis, and at this very point they will meet, and here you will get A dash and an image will be formed here. This will be B dash. The specialty, what are the different specialty that you can see here? Where is the image formed? What are the different properties of the image formed there? So the various properties are seen here. That is, image is formed beyond C. Next thing is that the reflected rays are meeting in real, so definitely you will get a real image, and all the real images are what? Inverted image, and definitely you can see here, that is the image form is enlarged, that is A dash B dash is greater than AB. So definitely you can see that an enlarged image is formed there. And especially note that it is not necessary that you should take like this. You can also take according to your wish. That is, this is also one scenario. So here this is I, so definitely this will be moving according to the law of reflection, and you can see somewhere here through this particular point. If I'm just taking R, then definitely it will move like this. So it's up to you during the exam which ray you should take, it's up to you. It's not up to the teacher who is teaching or up to the textbook, but make sure that you should draw it according to the law only. That's it. This is the only thing, nothing else. So here are the various properties that is formed and that you have seen while image formation if you keep the object between C and F. So moving on directly to the next case, that is the object is placed at F. What will happen there? So this is the scenario that the object is placed at focus now. The object is placed at focus. So here again the object is AB. So I am just from this particular point, from A, ray is passing parallel to the principal axis. So definitely it will just move through the focus and moves like this. Okay, fine. The reflected ray is moving like this. Next case, I am just drawing straight to the pole. So this is I. So angle I is equal to angle R. So we got two rays there, and closely observe that these two rays are equidistant from each other. That is, they are parallel to each other. They are parallel to each other. So how they will meet, or will you get an image there? Definitely. You have seen in the beginning in the prerequisites that if two rays are moving from a point from the infinity, then they will be parallel to each other. Just think in the vice versa case. That is, if two rays are moving, and then definitely they will meet somewhere at the infinity. Then at this very point, you will get the image there. That is, the image will be so large that it is too large, right? So you can say that is, this one is A dash, this will be B dash. I hope that you got the point there. So here, what are the different properties that you will get in this very case? So these are the properties that you are getting. That is, the image is formed at infinity. Next thing is that they are meeting in real. So definitely they will be real, and all the real images are inverted. And what about the case? They're too large. So highly enlarged. Going directly to the next case, the very special case in the concave mirror. So let us see directly what happens there. So this is the case there. Now the object is between P and F, pole and principal focus. So the same case I am just drawing, that is a ray from point A, then it will just move like this, as this is I and this one is R, right? And the next I can draw like this also, but a problem is there, a logic problem. That is, if I'm drawing parallel to the principal axis, then definitely it will just move through the focus, but the object is a hindrance to that particular ray. So I am just drawing in a different way. That is, a ray is passing radially. Radially means through the center of curvature. That is, through the center of curvature. That is, the ray is passing radially. Then definitely use a logic, that is, it will just rebounds back. It will rebounds back and pass through the center of curvature. One ray is moving like this, another ray is moving like this. That is, they are deviating from each other. The difference between, or the distance between the two rays are increasing. So they will not meet in real. At any point, they will not meet in real. So there is a big issue. So one very important logic that you have studied, or very important procedure that you have studied in physics and optics, that is, in such cases, what will be there? You will extrapolate, extend the reflected rays backwards, and you can see this extension will meet at a point, and it seems that from this particular point the reflected rays are passing, or it is emerging out. So at this very point you will get what? The image, as these two rays are forming or originating from point A. So definitely this will be A dash and this one will be B dash. So this is the only case where the reflected rays are not meeting in real. What are the different properties that you can see here? So the various properties are: images are formed The image is formed behind the mirror. And next thing is that they are meeting, or the reflect rays are meeting virtually. So you will get what? A virtual image. And all the virtual images are what? Erect image. They are erect and they are enlarged. This is the only special case in the concave mirror where you will get a virtual as well as an erect image. So that's it. So these are the various image formation cases that you can see in the case of a concave mirror. So that's it for today's class. I hope that you got the points. So just if you have any doubts, just pin your doubts in the comment section. A small request is there from my side that if you're drawing, just pause the video, just draw yourself and see what are the things that you should keep in your mind, and make sure that the distance between pole and principal focus as well as focus and the center of curvature, it should be equal. Then you will get approximately or equal answers. If these differences are there in your drawing, then definitely you will end up in wrong answers. So make sure that that particular distances should be equal, and draw practice. Don't think that this is an easy task. It's a bit difficult one only. So make sure that you will draw thoroughly, because you will get definite question from this particular portion for your board exam. So stay tuned. We need your support. Like, share and comment and subscribe, and that's it. Thank you. Have a nice day.